Okay, so for this afternoon, we will be discussing our laboratory statistics. So I believe you already have your epidemiology and biostatistics last semester. So most of these topics are actually quite familiar to you guys. So for now, let's talk about the outcomes that are our goal at the end of the topic. So at by the end of this discussion, you should be able now to define the different important terms with regards to laboratory statistics. Secondly, you should be able to differentiate when to use your descriptive statistics and your inferential statistics. Third, for you to be able to explain now the importance of statistics in quality assurance. And last but definitely not the least is for you to be able to calculate you yourself, okay? For you to be able to calculate a reference interval using parametric and non-parametric statistics. So always remember that inside the laboratory, there are a set of reference interval or reference range where we compare our laboratory result for us to be able to know if a particular patient has an increase, a decrease, a normal, or an abnormal laboratory result. So those are also being calculated inside the laboratory. So these are your reading guides. So I'll be posting a copy of this PowerPoint presentation for you. And at the same time, I will also be giving you copies of the reading guide so that you all will be guided during your review. So for today, I think I'm just gonna discuss until the descriptive statistics. So the comparative and the method evaluation would come next week. Okay, would be during the asynchronous class. All right. So now let's talk about the basic terms in laboratory statistics. So the first one would be your variable. So what are variable in the laboratory? Variables are the things that we measure, we count, or otherwise we delineate in a particular we delineate inside the laboratory. So again, what are we counting? What are we measuring? What are we assessing inside the laboratory? These are different variables, and these variables might come or might be represented in three different scales. Okay, we have three different scales of variables. We have your nominal, your ordinal scale, and your interval scale. What do we mean if the variable are of nominal scale? So these are variables where they can only take a limited number of values called your categories or your character. So when we are talking about nominal scale, these are an example of this are your gender, okay, only male, female, okay, or you can add up to that, okay, the LGBTQIA plus, okay, so plus 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 until letter Z. So those are the nominal scales. So take for example, nominal scale could also be just a simple category. Is it in or out, high or low? Okay, so those are nominal scale. They take on only a limited number of values. What about ordinal? Ordinal, okay, are type of variable that takes on a specific value that have some inherent order such as magnitude, but without equivalent distances between categories. So in your ordinal scale, ladies and gentlemen, when we are talking about the ordinal scale, um, the measurements here, okay, the variables here are actually they have an increasing magnitude, okay? They have a specific value, and that is a representation of an inherent characteristic or a particular magnitude. Take for example for your urine protein. Example natin are urine protein. Your urine protein can be quantified as to having trace plus 1 plus 2 plus 3 plus 4. So we have a set of order, an increasing order, and those particular variable, okay, your trace, your plus 1 plus 2 plus 3, they take on a specific magnitude or um, a particular characteristic alongside with them. Aside from that, okay, another example of your ordinal, okay, another example of your ordinal would be your Richter scale. Okay, tama ba? Richter scale for your earthquake. Okay, Richter. Okay, your Richter scale for your earthquake. Okay, so the magnitude of your earthquake. So you have your intensity 1, intensity 2, so on and so forth. So they also represent, okay, they take a specific value and they represent, okay, they represent a particular characteristic or a magnitude. They represent the magnitude of your variable. Now the most common, okay, the most common in the laboratory are actually your interval scale. Your interval scale is where a variable takes on a value in a quantitative range with defined differences between points. Okay, with defined differences between points. So in ordinal, there are no equivalent distances between categories. In your interval, they have. Okay, they have differences between points. So these are now the values that are given in the laboratory. Take for example, 125 milligrams per deciliter of glucose. So you can say now na it is normal, abnormal based on their value. So those are your interval scale, okay? Those are your interval scale. Now, moving forward to that, your variable on the other hand can also be independent or dependent. So your independent variable, these are already determined variables and is not influenced by any other factors like your age, gender, temperature, and your time. On the other hand, your dependent variable might change in response to what? In response to your independent variable. So your independent variable has a direct effect to your dependent variables, such as your blood glucose concentration, your enzymes, the presence of malignancy. All of those are dependent to those all of these are dependent variables, okay, because they can change depending on your independent variable. Now it leads me now to my question. Your independent variable can be seen in what axis? Is it the x or the y axis? Where can I see the independent variable, x or y? Chat box, everyone. Where can I see the independent variable? Is it in the x or the y axis? X or y? Independent, ha? We're talking about the independent, X or Y. Answers are what? Sabi sa mga sagot, ano ang nasa sagot? X, Y, Y, X. Okay? What about, okay, so let's clear that out, ha? Okay. So take for example, you have your ano, okay? So in your x-axis, okay, this is your x, this is your y. Your x-axis is where your independent variable is. Okay? Independent. Okay? And in your y-axis, nandito si dependent. Okay? Dependent. Another question. Your x-axis is also known as your what? What is the other name for your x-axis? Your x-axis is also known as your... Hello, are you there? X-axis is also known as horizontal. Okay? Aside from horizontal, in ordinate, okay? Konti na lang. Okay? Your x-axis is actually your what? Your x-axis is your abscissa. Okay? And your dependent or your y-axis is your ordinate. Okay? Your ordinate. Paano po siya mas mamememorize? Okay? Always remember, x is for your independent variable. Other name for that is your abscissa. So abscissa, x-axis, independent. What about your y-axis? Your y-axis is your, also known as your ordinate, it is where your dependent variable is indicated. Okay? So, axis and doi, abscissa, x-axis, independent variable. Your doi represents your dependent variable which is seen in your ordinate, also known as your y-axis. Okay? Also known as your y-axis. So, hopefully you will be able to remember that, ha. So, again, ha, independent variable, they are not influenced by any other factor, unlike your dependent that is greatly and much affected by your independent variable. Now let's move forward. Okay, we only have 7 minutes. So of course, moving forward now, we have now your Gaussian or normal distribution. So normal distribution is normal or Gaussian distribution is considered to be present if the spread of data in which elements are distributed symmetrically around the mean. So which most of the means are close to the center. And this is how it looks like. Okay, this is how it looks like. Ayan. So always remember that if your if your data or your data sets are normally distributed or in Gaussian distribution, the statistical treatment that we will be using there are parametric statistic. So these statistical measures um, are used. Okay, these statistical measures are used. These statistical measures that are calculated based on the assumption that the data points follow a distribution. Okay, and include parameters such as your mean, your variance, and your standard deviation. So again, we are using parametric if the Gaussian if the Gaussian distribution is present, if the data are normally distributed. Anong kabaliktaran ng parametric? We have your non-parametric. Non-parametric is being used, okay, makikitingin po ako sa chat box. Non-parametric is being used if the data are what? If the data are not, okay, are not normally distributed, okay, not normal distribution. In other words, the data are actually skewed. Okay, if the data are skewed, you use non-parametric, your non-parametric statistics. Okay, your non-parametric statistics. So I guess I can pull this off until 4 minutes. So your descriptive statistics, okay, your descriptive statistics will just be discussed on our asynchronous class next meeting. So that is it for today. So I'll be ending the